go ahead and look at that. Otherwise, I'm just going to point your attention to a few little things. But if you guys want to, I think it's number 5, right? Is that the baby bird one?
Yeah, 5.
Okay. So we're going to do that. Kiddos just joining us on the recording, just in case you missed today for AP Bio or whatnot. Don't stress about today's deadline. This is Monday, May 8th. Today's deadline of all the bonus materials. I will still take it Wednesday. Any juniors taking an AP not in class on Wednesday, I'll take it Thursday in class. Once again, I'm not extending the deadline for you guys to cram in a lot tonight. I'm extending it just so you can keep whatever you might want to study or look over tonight. In the 2012, we've worked together on it a lot, so that might be a little bit more beneficial than maybe other bonus practice exams you've done, etc. So if you want to turn anything in, totally fine. I also was bringing up the CalcAB live study session. I'm going to show you literally what I typed in. You probably didn't even need all this, but basically live study calculus con. Oh, hey, I did study twice. Go team. Anyway, if you type in something to do with live study calculus and con, there's going to be a video that shows up. It's probably, if you hit on videos, the top of the list. If you're doing anything, Google CalcAB live. I'm not saying that this is going to get you a 5 tomorrow if you were wherever. But what I am saying is this live study session does go ahead. There we go. Does go ahead. This is probably where I left off before. And talk about graphs. He talks about graphs. He talks about how to read graphs of derivatives. He talks about how to see connections between increasing and concavity and points of inflection and relative extrema. So he just goes through everything graphs. So if you're like, I hate graphs, there might even be some motion in here. People that watched it, was there motion in here? I think most of them were period 6. There might be some motion because sometimes they give you a graph of velocity. It just kind of depends. It is an hour long. You don't necessarily need to watch it, but some of you are like, graphs are a weak point. He goes through graphs, and people who watched it said it actually helped. I think that was a period 6 kid who has a very high grade in this class, and she was still like, it's always been kind of rough for me, and I think the video really helped. So anyway, if that's something that you guys might want to see, as far as with graphing, that's a weakness, you could just Google that. All you have to do for me in order to get that either bonus hour of tutoring if you are all done, or an hour of tutoring. Remember, that's due by finals. So that's not necessarily a stress, but since you're studying for the AP, it's just to take a screenshot and show me a little bit of work at some point. Take a screenshot, show me a little bit of work at some point. I probably won't take this one past Wednesday or Thursday, though, just because I don't really think it's very helpful to you or others for you to watch this past tomorrow. Anyway, I'm going to take that away. Huh? I'll get a 5 in 1 minute. Hey, there's stuff to watch. I don't quite like some of the videos. I think A-Push and other ones like that zoom through the course, I think those are a little bit more useful than the calculus ones that zoom through, but that might not be bad. I was showing you guys, if you search con and calculus, there's going to come up the practice problems as well. I just wanted to remind you, they do have literally every topic in calculus. And yes, there are instructional videos, and no, I don't think you should watch all of the instructional videos tonight. Long story short, you don't have time. But there are practice problems after every instructional video. So if it's something where you don't like infinite limits, or you don't like definitions of derivatives, or some of the different chain rule you just really keep on making mistakes on, etc., 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 go find that topic. Go do a couple sample problems. Maybe watch a video on it, if that's something you want to do. But my advice, one more time, is not to get very specific tonight. If you do look at one type of problem, like say a derivative one, go look at an integral one. Go look at a limits one. Don't just narrow your mind tonight. That's not going to help as far as tomorrow. And then, of course, they also go through lots of FRQ questions. They go through lots of FRQ questions. Okay, there's only one more resource I'm going to point your attention to. And guys, literally, I'm just throwing stuff out there. And I've been throwing it out for a while. Some of you guys are scared about FRQs. And you've been scared. Hopefully we've alleviated some of it and trying to show that they are possible with all the studying, all the practice that we've done. But underneath your shared folder in AP Exam Prep, yes, there are the bonus exams. Yes, there are solution keys to all those practice exams. Under advice, tips, and tricks, some of you guys might want to look through some of this stuff. The calculus cheat sheet is basically our forevers, how to survive the calculus exam. If you just kind of want to think about like what mindset should I have going in, quite a few of these are good in different ways. Things I wish I would have told them, we actually might go over this in just a second. But the nice thing is, I know what this all says, and I've basically been teaching you it all year. Like, stick it to the man on FRQs, but make sure that you've plugged in first or solved the integral first if they tell you. Like, how many decimal places? 3. Okay. Hi, guys. Anyway, we might go back over that, tips and tricks. But if you guys look at the very bottom, writing on the AP Calculus exam is what I have open right here. This one is really nice in the sense of this is that guy who's like everything king of calculus in the sense of the exam. And he does go through what most of us are most scared about, which is whenever they tell us justify, explain, why, give a reason, explain the meaning. Okay, he has the different wording of the exam that can show up. And he basically goes through and says, okay, figure out which theorem or definition applies, state it. I say find the forever part that applies. State it and then give a since this and this and this and this, or this occurs because, or when, this and this and this, which occurs at. You guys have seen me model quite a bit of that. But he goes through and shows things like continuity. He goes through and shows things like increasing and decreasing in speed. He goes through and shows things like extreme values as far as the absolute extrema, absolute mins and maxes. So he goes through very typical justify, explain problems, which is also very good with actual APs with a question, and then he goes through and makes sure you see the answer. Anyway, that one again is called Writing on the AP Exam in your folder. All right, cool kids. With that, let's go ahead. Let's just try to finish the 2012 questions you guys have. Some of you might have finished them this weekend. Some of you might be like, oh, I just really want to know how to. I don't want to leave you hanging the day before the AP. So let's start with the baby bird FRQ. That's number 5. I think you guys were letting me know. I left that one till today anyway. This one does have to do with rates. This one does have to do with growth. This one does. Someone I think said A, and then they're like, actually, I really want to do it. So that's what we're going to do. Just go through the whole thing. This one has a differential equation. What does this not have? Question. Let's keep your mind broad. If you have a limit problem, what's the very first thing you should try to do?
Plug it in. Plug it in.
But what if you get 0 over 0? Or infinity over infinity?
L'Hopital.
You could do L'Hopitals. But what is L'Hopitals? What does it say to do?
Derive the top.
Derive the top, derive the bottom, then try again. Plug in again, right? What if you're taking a limit, you plug in, and you don't get 0 over 0, but you get a number over 0?
You have a vertical axis?
Yeah, it's a vertical axis, right? We have to figure out, are they agreeing from both sides of the point, so it's positive infinity? Are they agreeing negative infinity? Plug in something like 1.9. Just kidding, that'd be hard back here. Plug in 1.9 if you're trying to go to 2. Plug in 2.01, see if it's positive. Because maybe the limit does not exist. The limit will never exist if the one-sided limits do not. What if you have a limit and there's a hole? So it looks like this, right there in the hole. Does the limit exist?
Yes.
Doesn't matter what's going on out. Alright, cool kids. Anyway, I had to throw in some limits because they're definitely not in this question. So, the rate at which a baby bird gains weight is proportional to the difference between, they give all this blah blah blah, and then guess what? They give me the equation anyway, so I can kind of ignore all of that. Except they do say at time t equals 0, this is what I would call a clue, right? Yeah. That's an initial weight. If B of t is the weight of the bird in grams, okay, there's a few things I should remember, like grams is the weight, t is days. And then it goes ahead and states the clue for me in a couple ways. It states the clue here in words, and it states the clue here in notation. Kiddos, if they ask, is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams faster? What am I looking at for faster? The amount its weight, the rate at which it's growing, or the rate of the rate at which it's growing?
The rate.
Just the rate. How fast? The rate. What stands for the rate in this problem? dB dt. So all I gotta do is say, what is dB dt? At, what's it say? When it weighs 40 grams. Question, hold on. Is Is that B or is that T?
B.
Good. If we look back at our wording,
There is no
B is the weight, T is the days. Okay. Such that B equals 40. And d v dt, the rate at which it's growing, how fast it's growing, that's 70. All I have to do is plug it in, and I plug in 1/5. 100 minus 50. Do I have to make that look pretty? Not necessarily.
40.
1/5. 100 minus 70. Question. Can you tell without even doing all the math which one's a bigger number?
Yeah, 100 minus 40. The first one.
Gracias. I was got the point wrong. I don't know how I got this one. I guess I said this before. Does anybody else start making mistakes when they're talking and trying to do something at the same time? Question. 100 minus 40 a bigger number or 100 minus 70?
40.
Since d v dt is greater when, guys, use the wording from the question. It weighs, except I've always told you never use it, so you can say when the baby bird weighs. It's usually for a different type of problem, but that's okay. When the baby bird weighs 40 grams, the bird, maybe it's not a baby anymore, oh well, is gaining weight faster at that time. Of course, there are a few different ways of saying it. The FRQ, sorry, the answer key probably said it a little bit different. But the point was test the rates, whichever one's higher. There we go. And since the derivative is always positive, interesting, up until 100. I'm thinking it maybe can't weigh more than 100. Anyway, get that over. You can't fly anymore. Gotta make you smile before the AP. Test the rates, which one's greater? The rate is positive, so the weight is increasing. That's a drop down. So we have the second derivative. Base letter B says find the second derivative. Can anybody tell me the process if you have a derivative and you take another derivative that we probably will be using? How do we take a derivative of what we got up above?
Oh, you just take the second derivative.
Yep, take ddt of both sides. Take ddt of both sides. You're finding the second derivative. What I was looking for as far as how to take the derivative, implicit differentiation. Now, technically, if you guys can think about it, it might be a little easier to distribute this first, because right now I have product rule of both. I don't like product rule. I don't know about you guys. If I can not do it, if I can avoid it, I typically do by avoiding it or something else. So I'm going to go ahead and distribute this 1/5 carefully. Very carefully. 1/5 of 100 is 20. Double checking, is it 20?
Yep.
Good. I'm going to take ddt of that shebang. It's a little bit easier. And over here I do have the second derivative. And guys, they showed you how to write it in the question. Just write it the way they did. And how do I take the derivative of 20? 0. How do I take the derivative of negative 1/5b? Negative 1/5. Don't stop there. dv. That's like a y. dy. Think of the variable, it's a b, and that does not match the t. If it was 1/5t, the derivative would be 1/5. Negative 1/5t. Now wait a minute, hold on. How am I supposed to figure out that? It's not like I know anything about dv dt, or do I? Plug it in, plug it in. So from up above, you guys keep me on this, because I have to keep on scrolling in and out. It's 1/5 times 100 minus b, right? 1/5 times 100 minus b. Now, why am I boxing it? What am I modeling for you?
Stick it to the man.
Stick it to the man. Don't make any silly mistakes. Make them deal with it. They will. They can. They're a master at this question. They know all the different ways of answering it correctly. You'll be fine. But before you move on from the question, if you've already started it, you may as well just make sure you've answered it to the best of your ability before moving on, unless you see just time to reign. already read it, we've already started it, so let's go ahead and look back really quickly. Find it, check, that's done. You can put a little check over it, and then, why the graph of B can't resemble? They gave me a wrong graph? Those little stinkers. They gave me a purposely wrong graph. Question, how do these two not go together? If the second derivative is what you see down below, for B between, it starts at 20 and goes to 100, which is the range that we see right here, why do these two not make sense?
Concavity.
Huh?
Concavity.
Concavity. The second derivative shows what?
Negative.
Yeah. Since d squared b over dt squared is negative, for b between, I think it hits at 20. Does anything that I can't go past 100? That's kind of mean. Currently, virtually. In the equation, it kind of shows that the bird, we'll just say between 0 and 20 and 100. At 100, it would be 0, so we gotta be careful for that. The graph would be should be concave down. Can you put CD and I know what you mean? Yes, if you want to write it out, the super sad. You can as well. Should be concave down, and that one's concave up and down. Does that make sense to you? That little negative says concave down, that graph's good one, and it's not. To be honest, that's the first time in quite a while that I've seen them give you something wrong and be like, show me why it's something. But they can. Why am I going to take just a second to remind you of letter C?
Because it's
Having negative lines.
point condition,
A
particular
is going to tell you separation of variables. B, there is an initial condition. And C, I see that as a poor compliment. I see them wanting me to go back to an original when I have a differential equation. Now, kiddos, you gotta go back to the beginning of the question and say, how can I get there? Well, they must have given me something important in the beginning, and they did. They gave me a differential equation. Keep me honest, because you guys have it right there, and I have to scroll back to the back page. It was 1/5 times 100 minus b.
Yeah.
Now, my advice still holds, even though the variables are different. What's the very first thing you should do to get to b, who's right here?
Multiply by dt.
Multiply by dt. Usually it's multiplied by d. This one's multiplied by d. However, only get you the answer. So what's the first step?
Multiply by dt.
So we go ahead, we get dt to the other side. Some of you guys might want to do what I did before, which was make this look a little bit prettier. Just please make sure if you need to off to the side that you can go ahead and do this division. 5 and 10 is 2 minus 10 minus 0, 5 and 0 is 0. There's no shame in doing simple math off to the side. Anyway, I go ahead and distribute. Except what's the dilemma? I have dt over here.
Yeah, and you have b.
It might have been easier if we just left the 1/5, huh? Okay. So even though it was good in an earlier problem, it might have been easier just to leave it this way because the b is more alone this way. What are we supposed to look for, kiddos? Can I go take an integral right now?
No, you have to make sure that it's on the right side.
Does that b match that t?
No.
Let's get rid of it then. 100 minus b? 100 minus b? There's a lot of things I like about this problem. Now that we have everything proper in its place, what am I going to tell you what to do? What am I going to tell you to do next? Making it look pretty, but I'm making it look pretty so that I can better integrate. We gotta go backwards. Better be used then. I'm gonna do the right hand first because it's easier. Keep it constant, and I need my t plus c. How many of you guys at least see that we need ln on the left? Good, it's one over u, right? Why did Katrina say you suck?
Because you got a negative.
I got a negative by the B. So I need to go ahead and say U is equal to the whole bottom. Don't cut steps. Don't cut steps.
So what if you can make this jump mentally though? Just
Don't
get straight to
skip
the
steps.
negative ln of 100 minus.
That's not skipping steps. Does that make sense? You're going through them, just you're going through them.
Okay, gotcha.
But for those that aren't going through them in their head, don't you dare just go to ln. Negative ln.
Yes.
Or if that was a 2, 1/2 ln, yes.
Okay.
However, you better go through those steps. Think you said always. So, I go ahead and I solve for dB. So when I go to plug in, no shame in taking a little longer on one than the other. I have 1 over u du with a negative. Some of you might get here a little faster than others. The point is that you get here. Right, that's another answer to your question. The point is that you get here. All right, cool kids. At this point, what do I need to do? I have two choices there. It's a fork in the road. I can either go plug in stuff right now to get C, or I can be going to go get B. What do you guys think? Is Ella being quiet? She's not, is she? Oh yeah, this first period wouldn't matter.
And she's sick.
Something spread it again. Kiddos, what do you want to do? Plug in the clue, or do you want to solve for B?
Well, solve for B.
Okay, I heard solve for B. Some of you might go plug it in to get the clue. Both routes are totally valid. Aaron, you helping people focus?
Yes.
Okay. So then we divide by a negative. We get negative 1/15. Can I put a plus C still? Divide by a negative? I can just say that C is going to be a negative number, or it's going to be negative of what it was before. How can I get rid of ln?
E. Exponentiation.
Question. What happens over here on the right hand side with my e to the something plus something?
C pops down.
Multiplication. So
C becomes a multiplication. Good. Now technically, kiddos, at this point, the clue becomes very important. It doesn't necessarily become very important right this second, but it will eventually, because depending on the clue, C could be different values. That's what that absolute value is showing us. There is the slight possibility they do something about state the domain for the differential equation this year. But to be frank, it would be 1 point out of 108, so I'm not going to stress about it the day before the AP. There's a slight chance they might actually ask you to state something to do with domain. But what we've been doing will help us, will get us to the final solution as long as we do it carefully. In that, I tell you guys to just go ahead and take away the absolute values, realizing that a positive or negative, depending on the clue that we have, will be seen in that C value. They might ask for a little bit more notation for that this year, but that would literally be 1 point. We're okay. If we subtract by 100, and subtract by 100. Oh no, but that's a negative B. How do we get to a normal B?
multiplied by
Multiply everybody by a negative. So 100 is now positive. This guy is now the subtraction. Kiddos, what do I need to do before I can finish? Yeah, and done C. So let's go ahead and plug in. You guys can read the question, right? What do we got? 0, 20? Is that right?
Steve,
Yeah.
if you left it as C e to the negative 150 plus 100, would that work? Because
Yeah.
like
Yeah, that's okay. I just, in my mind, I like it a little bit differently, but yeah, that's okay. As long as it's equivalent. When we go ahead and plug in off to the side, I'm going to do that over here just because there's more room. I'll come back and write the final answer below. I end up with 20 is equal to 100 minus C e to the, what is it, negative 1/5 times 0, 0. Is it even 0, 1? So I end up with subtracting 100. Yes, I do tend to show more work when I'm trying to be very careful about an answer. Do you guys agree that C is 80? I have my final. If you want to make it look like they did in the question, y equals b of t equals 100 minus 80 e to the negative 1/5. Technically, if you think about this little 100 minus b's worth in absolute values, you could go ahead and think about that domain restriction. If you guys want to Google it tonight, you can. If that's like, oh, I have everything else down pat, so I want to go fight until that one point, but otherwise, please don't stress. Kiddos, we've gone through as far as what you guys had asked on Friday, all the FRQ questions. There might have been some earlier, so let's just see. Some of you guys are working on 2012 this weekend. Is there something else that you guys want to see real quick?
For the effort choose on number 1, part B, can you just explain the explanation part?
And remember, don't be shocked. You're going to see on the FRQs the table at least once. Equation at least once or twice with your friends. The graph at least once. Words for every single one. So this one we have a table. This one's talking about temperature of water in a tub. Whatever. They can talk about snowfall. They can talk about someone riding their bike. They can talk about gravel being processed. They can talk about water in any way, shape, or form in a tub, in a teapot, in a tea kettle. Anyway. In what else did I say? In a dam. In some sort of weird shaped cylindrical container. I don't know. They can talk about who knows what. Don't be scared by the situation. Just think mathematically and say, who cares what the situation is? Except I'm going to use the units in the answer. Let's figure out what they gave us. So, they've given us an amount. It's not a rate. There's no per hour, per day, per minute. They've given us an amount, which is kind of like a position, kind of like an additional function. They tell us strictly increasing, twice differentiable, whatever. There are some clues. They give us degrees Fahrenheit and minutes. They also give us, anybody else see the clue? They give us an initial temperature of the water before it starts heating up. The water is heated for 30 minutes. Don't know who necessarily fills a tub with water and then heats it. It's like we're back in like the 1800s. Anyway, the water is heated for 30 minutes, beginning at time t equals 0. Juniors in the back. Values of W of t at selected times are given in the table above. Whatever. Letter A, hopefully you guys know to use W of B minus W of A all over B minus A using 9 and 15. Average rate, right? What would the units be in that letter A? I'm just going for it since you asked about B and leading up to it. What would the units be in A?
Degrees Fahrenheit per minute.
Good. So remember, W is measured in degrees Fahrenheit. T is measured in minutes. You guys can get there if you just look at the units. Now, even if you have no clue how to find this, write down the number and write degrees Fahrenheit per minute. You might get a clue. But, guys, sticking to the man isn't stopping there. Sticking to the man is plugging in the numbers and then saying, shh, my time's too precious to do that math. This is sticking it to the man. Using correct units, this would be the average rate of change, or the average rate at which the water in the tub is heating. That's approximate to W prime. Well, I guess I should have shown that. At which water in the tub is heating for T within. Where are we going? 9 to 15? You guys already put the degrees Fahrenheit per minute, but you could go ahead and say in degrees Fahrenheit per minute, because they said to include that in the explanation. So, dW over dt is the rate. Now, letter B changes just a little bit. However, this shouldn't be totally unfamiliar to you. I know there's a W, but question. How do we make the integral of a derivative with bounds?
It's the original. So you do
FTC part 2 is the original, but it's not just capital F of X.
What about part 2?
It's part 1.
Is FTC one?
Yeah, it's FTC part 1. I need B minus A. So I need the original W of B minus W of A. So we can say the integral from 0 to 20 of W prime. Remember the antiderivative, you go back. How on earth can they expect me to find that? W of 20 is 71.0. W of 0 is 55.0. Now, kiddos, just look at the units. Who's involved in this? W. T is involved between 0 and 20. The antiderivative of a rate is an original. So what would my units be? Degrees Fahrenheit. Can that help us in interpreting? We're not done yet. You've already worked so hard on this question. Make sure you didn't forget something. Using correct units, interpret the meaning. Well, W is temperature. 20 is after 20 minutes. And W is temperature, 0. Oh, what's this talking about? The change in temperature. Now don't say total. I don't like using much because the absolute value is strictly increasing, so it technically would be okay in this case. I would just say the change. So I would say which represents the change in the temperature of the water. Now it's good that you've gotten this temperature of the water. You could say water in the tub, whatever, in degrees Fahrenheit. But don't stop there. The 0 and 20 has meaning. The change in the temperature of the water in degrees Fahrenheit. You can say from T between or for T between 0 and 20. Or you can just look at this and say T is measured in minutes. The water is heated for 30 minutes. Oh. The change in the temperature of the water in degrees Fahrenheit after being heated for 20 minutes. I'm just trying to show, you could do from T between 0 and 20 minutes. I'm just saying you can use what the problem says and just kind of make it your own and say, oh, that's right, the water's being heated. Oh, hey, it's only being heated 20 minutes. Oh, that's what changed in the temperature. Alright, guys. We've done a table problem. You can do other things like how letter C is the average temperature. Oh, they tell you the average temperature? That's lame. Usually they ask you the other stuff. So you can talk about over or under estimates. Let me help out with over and under estimates for letter C really quickly, but I'm not going to do it necessarily in C. Let me just do it this way. How do you know whether to tell whether something is an overestimate? This actually might be a forever code next year. We just kind of underestimate.
I mean, we have an extra 5.
We do. You could make it number 50. There are usually 2 different ways in CalcAB that they ask for over and under estimates. It's either for tangent lines. Ooh, hey, that's a forever card. When you see. When you see. It's a good thing to look at too. Forever cards. When you see equation of tangent line, what should you do? Y minus y1 equals pause. So how did I find this? Derivative. It could be dy dx. It could be dt. It could be at prime of x. I don't care. Derivative, but derivative plugging in the point, right? You gotta get a number for the derivative or else it's not going to learn anything. So y minus y1 equals m. Find the derivative plugging in x times x minus x1. If they don't give you the y, you better be, it has to be something to plug in to find the y. Okay, so tangent line. How to tell whether a tangent line is an over and under approximate. That's one question that over and under can come up in. However, the next question is what is in this FRQ letter C, and that's reading side. Okay. So, tangent line is going to be an over estimate if the original function, I'll just name him f of x because who knows, it can be w, it can be b, it can be t, it can be average G or H. If f of x is concave down, let me show you a quick visual. Whatever part concave down, you don't have to show this visual, but a tangent line will always, a tangent line approximation, I should say, will always be above. Ooh, tangent line approximation. Find the tangent line. Plug in the new x value. Tangent line approximation. It will always be over if f of x is concave down, and it will always be under if f of x is, well, what do you guys think? You need a visual. Whatever part of a concave up, whether it's decreasing the function, whether it's increasing the function, tangent line will always be over. 3 minutes left. They should only ask for left or right, or trapezoidal. Don't usually ask for midpoint because that kind of depends on the graph side. If ones are messy. If you think about it though, based on a function, I'm just going to make it linear, it's going to be a little confusing. Let's do this one. Let's do decreasing and increasing. So if f is increasing, and if f is decreasing, let me go ahead and do, let's see, we have left, we have right, and we have trapezoid. If we were to do left, of decreasing, left is going to be an overestimate. If we were to do left of increasing, it would be an underestimate. If we were to do right of increasing, it would be an overestimate. If we were to do right, see if I didn't make it a perfect curve yet, it's messy. A right of decreasing would be an underestimate. And last but not least, if we were to do a trapezoidal, I'm just going to do one big one, it shows the idea. A trapezoidal of increasing will be over. If we were to do a trapezoidal, so left and right, long story short, we want to look at increasing, decreasing of f. Trapezoidal, we need to look at CalcAB. And once again, we're majoring on the minors. We're majoring on the minorship. So let's go ahead and take a step back from the minorship. I think we need this. Let's remind ourselves of some more of the basics. Question, kiddos. We go to the end of 2012. I technically had other stuff I need to do, but right now I was just going to do this question. I'm going to go ahead and just stay here. Go ahead.
How to justify it, do you just say because it's left or right?
They'll say left or right, like they'll give you one. And then they're going to say, isn't it over or underestimate? You can literally just say, this Riemann sum isn't over. Let's say it was a left, and the function is decreasing. Okay. You could just say, this Riemann sum will be an overestimate since the function, make sure you name the function, just say, hey, the function is decreasing. You don't even have to go through the left and the right or show a picture. Just say decreasing or increasing and which one. Alright, so kiddos, let's do some random stuff, ready?
Inverse function.
Underneath, underneath AP exam review tips tricks, there is a document called the most missed AP calculus questions from the past, something like that. You'll find some inverse. Question. What if I was just to randomly say something like, find the derivative of sine squared of 3x? What you gonna do? get better. Sine of 3x squared. How do you get the derivative of u squared?
Bring the 2 down.
2
And you subtract
u times u prime. Okay, hold on. How do I do that?
Alright, then it's the sine.
No, it's
Derivative of the sine is?
Is cosine 3x, and then it's
And then
times 3. G of f of
an
x.
f of g of h. What if I was to go ahead and give you the integral of sine of 5x dx? I'm not even doing it. Use that will lead us to
Yeah, so 20 divided by 4 is fine.
kiddos, pause. What do I expect from you today? Get sleep. Eat healthy. Wake up tomorrow and get here early. What time am I gonna have breakfast in the gym? 7:15. Do you have to be here then? No, but be here early. Or else. Do you guys want your forever finals come in before the end of the day? 7:30.
Miss D, can I get my forever final?
Right this second. Mine happens to be done. I have the -5 and the 4. I don't have a total. Can you get it out? See?
Yeah. I did terrible, huh? I think like.
-5 and 4. That's
Say that
4.
eight and then I'll win.
Let's scale back.
I don't like it.
The two other tests are both actually good. The one using that one and the other one. Because yeah, I couldn't expect to see that. Nice question.
I'm doing one right now, but the one that I did before this one, I only got like a couple, like, I had the same, literally the same numbers as my last one.
She's not your mom, she's my mom!
My mom, Katrina.
I want to narrow your focus.
No, I
So at the end of the day.
some bigger ideas that I'm confused on that I wrote down, but
And I'll remind you tomorrow, forever is when you see you think.
At what? Say at what?
Doing alright, buddy, how about you?